This is in your notes. It's, I'll start recording. Okay, great. Okay. So, as we look at this one, okay, so we have this whole stem that's kind of describing, we're taking we know from the stem that for all people, the mean systolic blood pressure is 122 with a standard deviation of 15. And we are taking a sample of 100, okay? And from this company. So the question is this is the mean of everybody in the U.S. The company wants to know how do they compare to the U.S. So we don't know the true mean blood pressure of the company. We only know that of the United States. So mu, and like as I'm looking at these hypotheses, mu is of the employees of the company, not of everybody. Okay, so mu is unknown. We don't know what it is. We're checking it against that hypothesis size value that came from like the all of U.S. as a whole. Is everybody okay? All right, and so we have that the true mu equals 122. Our alternative is greater than, and part A is just saying describe a type 2 error in the context of this question of this test. So as you're looking at this, is describing a type 2 error a reasonable thing for me to ask you guys to do, having been through the course? Yeah, this is what I mean when I say question 6 will have components that feel very, very reasonable, hopefully. Because part of it should come from something you've done in class. Okay? So, your type 2 error, what do you guys think? We never conclude the null hypothesis. Okay, so I might say the true mean blood pressure, systolic I should say, blood pressure is more than 122 millimeters or whatever. But we fail to meet that conclusion. Cool? It's not asking for me to describe a consequence, so I don't need to. All right, let's look at the next one. So what this is saying, okay, they gave you everything you need to know about the sampling distribution of X bar. Okay, what that means is each dot on this dot plot, if this were a dot plot, right? Like we could make a dot plot underneath here. Each one of them is the mean of a possible sample of size 100. Now, they didn't need to tell us this. I could have asked you, describe the distribution of X bar as approximately normal, because my sample size is 100, right? If my sample size is 100, it's greater than or equal to 30, we're good, right? Okay, the mean of the X bars is 122. The standard deviation of X bar is equal to the population standard deviation divided by the square root of our sample size. That's a formula on our formula sheet, yeah? We know that. And we knew our standard deviation of our population was 15. We know our sample size is 100, and if I do 15 divided by the square root of 100, I end up with 1.5. They gave us that information. They gave us more than they needed to. Is everybody good? Now, this is essentially this whole question is based on if the null hypothesis is true. Because we're assuming the null hypothesis is true the minute we said mu equals 120 or 122. Is everybody good? Okay, now, even if the null hypothesis is true, is it possible that we could get a sample that makes us reject that null hypothesis and make a type 1 error? Which kind of samples would make that happen? High means or low means? Look at your alternative. High. So are you guys with me that there's a set of samples over here whose p-value would be less than 0.05? Is everybody okay? Right? And in fact, if I want to find, if I make that 0.05, I make that alpha, that tail, anything in that tail is where my p-value is going to be lower than 0.05. Is this okay? And what this is asking for is which values of x bar would make us reject anything in that tail, yes? How could we figure that out? Just use inverse norm. What are we finding? Okay, you got to put in the left side area. Okay? Yep. It's very lovely, the face you were making of like you knew your answer didn't make sense. Are you guys getting, it's like 124.7? 0.47. 0.47. Does that work? Yeah. Okay. I would argue that this is within the scope of the course. Not everybody would argue that. Does this feel okay so far, though? All right. So, when we move on to parts C and D, which they give you a whole lot more space than what I give you guys. I obviously try to save some paper here, okay? When we get to parts C and D, they're saying, oh, we got a new reality, and that is that we do know the true mean of the company, that it's 125. And if it's 125, all of a sudden the mean of my sample means will be 125. But my standard deviation is still 15, so my standard deviation of my sample means is still going to be 15 over the square root of 100. So this is still going to be 1.5. So but if we look back to part B, when are we rejecting the null hypothesis? If we get a sample mean of 124.47 or higher. So what's the probability that happens? And when we do that, that's a normal CDF question. Now, we could write that as it's the probability x bar is greater than 124.47. Another way I could write that is what is the probability I reject the null hypothesis? And if the true mean is 125, should I reject the null? So really, it's the probability of a correct decision when the alternative is true. Does anybody remember the statistical term for that? Power. They had you calculate power. Now, the reason this question didn't go well is because they grouped those two things together and people struggled with this question. And then they struggled with this one. And they grouped these two things together. So a lot of people got a P on the top section. PII is a 0. I usually give you guys a 1, but it's technically a 0. Okay? All right, now, you guys tell me. If necessary, I'll ask guiding questions. Suppose instead of selecting a sample of 100, I go with a sample size that is bigger than 100. Would the probability of rejecting the null be greater than, less than, or equal to the probability to this probability? Another way of saying that, if I increase my sample size, what will happen to my power? Will it stay the same, increase, or decrease? Your power will definitely increase. Most people got that part right. Because you're making the correct decision, yes? The probability you make the correct decision will increase if your sample size is increasing. That feels right? Intuitively, that feels good. But man, explaining your reasoning to them, they had pretty high expectations here. Okay, so mathematically, what happens to these pictures if my sample size increases? Would the means change? The standard deviation, remember the standard deviation is sigma over the square root of n. If n is getting bigger, the bottom of my fraction is getting bigger, my standard deviation is getting smaller. So if n is increases, sigma of x bar decreases. So what? Why does that matter? Well, in some respects, this whole time, when I look at, say, this distance, that distance is, I'm going to call it 0.5 to make the math easy. Are you guys cool with me saying that this is that 124.47 is about 0.5 below the mean, which is 1/3 of the standard deviation. So this is 1/3 standard deviations below the mean. And in fact, we could call it z-score negative 0.33333. Cool? If my standard deviation decreased, all of a sudden that distance is more standard deviations below the mean. Everybody good? Like, what if my new standard deviation was 0.5? That could happen if I increase my sample size enough. Now that 124.47 is 1 standard deviation below the mean instead of 1/3 of a standard deviation below the mean. The overall distance is the same, but the relative distance, it's much further away for that to happen. Standard deviation decreases, meaning making 124.47 more standard deviations below the mean. so the probably X bar is bigger than 124.7 would increase. If it's further below the mean, the area to the right of it is bigger. And that was a hard piece for kids to get credit. This was a very, it's very rare that you take a 0 on question 6 and get a 5. And it happened a decent amount of the time here on this particular test.
How does College Board feel about abbreviations and stuff? Are they fine with that?
Yeah, as long as they can tell what you're trying to say. Or for instance, they would have up here, if you would have said, box this in and called this SBP or something, as long as you communicated it. Well, I don't know. So it's going to be a little bit different because you guys won't actually have that written out test. You'll have the questions will be on your screen and then you're going to write it in a blue book. Right? So I would err on the side of more communication than less until I have no metric for how are they going to grade that. I would err on the side of being as specific as possible until we start to get a feel for I have worked in workshops and stuff like that with a lot of people who are readers who go in and read the AP exam and decide who actually score your tests. And they have said that overall they do try to look to give you guys credit wherever they can.